Right, howdy folks, welcome back. So here we are, February 26th of 2023. We got our loop playing. You can see we've had a little disruptions here and there. This doesn't look like all the data though. Yeah, it stops at 10. We'll go check the other site here in a little bit, but first I wanted to show you our activity here for the moment. For today's sun activity, we'll find out more from this. Just before we leave this, I want to go back a day real quick and show you something that wasn't fully loaded from yesterday. And once this pulls up, okay, here comes our event from yesterday coming up here. Boom. All right. Almost done loading. You see all the debris that came with it and everything. Let me, oh man, I wasn't set up. I hit the button too early. All right, thank you for your patience, folks. All right, let me get this paused real quick on the right frame. Boom. All right, let's go back a couple. All right, quite the explosion, right? Here's our full halo. Okay, this is coming right at us, all right? This is a full halo CME that was produced by this object I showed you the other night, okay? So, it's definitely Earth directed. We have a full halo CME. It's very rare that we see a full red circle on this instrument, and that's why I wanted to freeze frame on this and at least get it documented for the record. Here we are seeing some of the activity on our list happening now on the sun. You know, this extreme activity. Well, here's a sign of our extreme activity. We're having a full halo, full directed, big CME heading our way. Okay. What else did I want to show you on this one? Okay, so we're missing data a little bit on the 26th. I showed you. Let's go over here to stereo. I haven't opened this one yet. Let's see what data we got here. Looks like we had something going on up off the top here. Some kind of CME activity or whatever. I don't see much going on there. I want to pause on that one glitch frame. Because sometimes in the glitch there's something. Nah, that's hard to tell. That's nothing. All right, on to the next. So this is some of the missing data from today. Apparently we've had something come off the top. We'll try to get a better view from a different site. Okay. So now as we go from there, okay, here's the other site. Now what I want to do and what's most important, hopefully we got some people in the room by now. Yeah, it looks like it. All right, here is the main part of our report tonight. The other night I was telling you about this first shockwave coming out and hitting us directly, right? Then the next night we showed a different shockwave, what looked like an adjustment. Now I was telling you there's actually two shockwaves coming, the first one with the second one behind it. And I had doubted if this instrument would update and show two shockwaves. But guess what? I was proved wrong. Let me zoom in a little harder on this for you guys, because I want you guys to see this nice and close like, okay? Here we go. We have the first shockwave hitting us and the second shockwave hitting us. The second one is coming out faster than the first. It's catching up to the first, right? That first event with the one object going in between us and the second event with the other object going on the other side is catching up to the first one. These two are going to hit as like a double impact, okay? Boom, boom. If you look over here, watch closely, you see a double impact, okay? So I'm going to let that run for a second and let you guys study it. Here it is, boom, boom. Double impact, okay? Now I've explained to you guys what's going on with the core of the planet, how it affects, how, you know, these CME impacts affect the core and the grinding of the core and the slowing down of it and stuff. This is not good for our situation, okay? Another thing I want to point out here too is the double punch, the double hit. The first one takes our magnetosphere, the magnetosphere absorbs it, but weakens for a second. What we don't want while the magnetosphere is weakened is another one hitting us, okay? This 1-2 setup is not a good scenario, all right? Now, this second one should be a day behind the first. But if you look, they look to almost hit on the same day. That double impact, that increased amount of radioactive activity bombarding our magnetosphere at the same time, this is going to be a much stronger impact. It's going to be a double impact. They're going to amplify each other, I think. Okay? So take a look at that for a minute. I want you to see exactly what I was telling you. There should be a second wave coming behind that first one, and apparently these guys are brave enough to show us the truth, because this is what needs to be shown. This is the instrument we rely on for this stuff, okay? This impact is due tomorrow on February 27th. The day and time, or the time, I'm not quite sure. I'll try to do calculations, but with the double one catching up with this, it can push the other one faster. It could slow it down. I'm going to stick with the 27th. Anytime tomorrow, brace for impact of the CME and a double CME hitting us. Now, this isn't the end of the world, okay? This is a major impact, and it will cause side effects on the planet. Like I told you, this is going to make the core squeal. We're going to see more of those spikes on the Schumann. Probably half a day after impact, about 6 to 12 hours after impact, you will see the squeals, okay? That's going to cause magnetic frequencies inside the Earth that are going to disrupt the Earth pretty well, okay? This is an important impact, okay? I'm not going to try to oversell it or whatever. I'm trying to keep everything under wraps here and stay calm. I don't think my calmness translates the sense of urgency in our situation here, okay? So let's just say you're lucky I'm not screaming expletives right now. I'm trying to do this matter-of-factly. Watch here real close. Double impact. Boom, boom. That first one has white intensity when it hits us, okay? All right, don't let this fool you that it's hitting on the side. They adjusted this more. The object, the first object, is due to go in between these two. Now, since we're talking about those two incidents, I'm going to come back here and we're going to refresh, all right? Here we are at February 25th. Let's go back a little bit. Okay, here is our object. Oh no, that's yesterday. I want to go back a little further to 24th, our event on the 24th. Okay, here we go. Boom. Not that event. Yeah, it was this event right here. Actually, it was cut out of this, but it was coming off to the left here, all right? On this perspective, okay? Then we went over to stereo A. If you guys were still with me, we went over to stereo A, and here we are. Whoops, that's the old one. Let me go back to the other one. Okay. So, stereo A, whoopsie. Stereo A was the one that captured the best on the 24th. This event coming off to the left. No, it was this event right here, okay? With this big old stretch of lightning. We had this object in here, okay? It came off to the right of stereo A and to the left of our perspective from the Earth. Where is it? That's our new one. Oh, it's missing the data there. Wait. Anyways, it's coming off to the right of this, or off to the left of this, from this perspective right here. It was this one. There it is. Okay? This event happened to the left of this perspective and to the right of this perspective, okay? Which puts it to the, if you're looking this way, I'm going to hold my little pointer through here. If you're looking this way, our arrow's pointing that way, okay? From that perspective, it's to the right of stereo A and to the left of this one, putting it in our variant zone that I use for my calculations to forecast trajectories, a rough estimate of a trajectory, okay? Now, amazingly, this object appears to is going to go in between these. So don't let this little sideswipe thing right here fool you. It's going to be going past this. So we're going to get a direct impact with another impact going just on the other side of us, okay? We're getting the double whammy, you guys. Now, depending on how these objects are magnetically charged, their polarity, we'll say, could do a little number on the earth as one passes by tugging one way and another passes by on the other side tugging the other way. We might do a little rock and roll, okay? If we do a rock and roll, you might see some catastrophic side effects, okay? And, you know, we made those lists. And if you want to know what to expect, look at your list, you know. For those of you that are new here, let's just kind of go over the list and explain the list because some people don't even understand how I came up with that list. Now, where are we? I'm going through notes here. Bear with me real quick as I take a sip. All right. Just real quick. Number 1, write down atmosphere collapse. Number 2, storm reversal. Number 3, record storms and record aurora. Number 4, calendared superstorms happening early. So 1,000-year storms happening early out of schedule, okay? Other calendared superstorms or events, calendared events happening early, okay? That's number 4. Number 5, penetrating radiation triggering storms, okay? You understand when radiation penetrates our magnetosphere, it stirs up the storm activity, okay? We were penetrating radiation. Number 6, clouds disappearing and reappearing. That also means storms disappearing and reappearing. Not just clouds, but storms. Clouds and storms disappearing and reappearing is number 6. Number 7 is the radio frequency change, okay? Number 8 is seismicity off the charts. Number 9 is new mantle activity. Number 10 is increased winds, maybe by a third or more. And then we got much more. But let's just stop at the top 10 right there. So hopefully you guys are writing these down if you don't have them or you got your list around, okay? Because that list came from Ben at Suspicious Observers, and those were the side effects that are happening to the outer planets and the sun. So Pluto experienced an atmosphere collapse. Neptune has storms reversed on it now, okay? What is it? Uranus, everybody keeps asking about Uranus. Uranus has record storms and record aurora, okay? Super storms and super aurora. Add that super to it, sorry. So record superstorms and record super aurora, all right? Number 4, whoopsie, where were we here? So number 4 was Jupiter, sorry. Jupiter had a change in their superstorms. The red spot disappeared and a new junior spot appeared and took over, okay? It was there were calendared events on Jupiter that happened early that they weren't expecting. Same with Saturn. Also on Jupiter, the penetrating radiation, something's happening to Jupiter that are triggering those storms, okay? It's being triggered by penetrating radiation, number 5. What was it? Also on Jupiter, the clouds, the storms were disappearing and reappearing. I told you the red spot, little junior spot. Okay. Also on Jupiter, the radio frequency of Jupiter changed. Okay, these are all scientific data that they're recording right now, happening to other planets. All right. Eight was Mars. Mars has seismicity off the charts. Mars does. Mars quakes, not earthquakes. Mars quakes are off the charts. Also, he reported that Mars has apparently a new mantle that is active now. So, little did we know, there is a mantle, which is lava and magma under a crust on Mars, that is now there and active. So active that it's causing seismicity off the charts on the surface of Mars. Okay? So these are side effects on other planets that we would expect to see happening here. The last one was Venus, with increased winds on Venus. Now, Venus is a wind planet, all right? It saw an increase of its natural winds by a third, okay? It's very important because that's what we're seeing here on our planet. Is our winds are increasing. This is all side effects of the electromagnetic conductivity between us and the sun and these CMEs. Okay. Do we cover the list? Okay, so um, let's go backward up the list now, just like they did the countdown starting from Pluto in. So when this double impact happens, expect to see increased winds, okay? Expect to see some kind of new mantle activity, okay? Because this is going to hit the core. The core is going to grind. It's going to cause mantle activity, right? Let's go up the list to 8. Expect to see new seismic activity that's off the charts. Where? Oh, here on our Earth. So you saw what happened in Turkey. I mean, we're very lucky that we haven't had anything bigger striking, but this could induce a bigger earthquake, okay? I'm trying to spell it out for you without being over dramatic or predictive or whatever. I'm giving you data so you guys can ingest it, all right? I'm trying to spell it out so in a more simple terms so you can wrap your brain around it. Now, where were we at? Okay, now it gets interesting. Not only will we see some new kind of earthquake activity, possibly with this, okay, we might see a radio frequency change, folks, and that means radio blackout, okay, for us. So that's like, where did I go with that? I have to flip the notes to the backside with the radio frequency change. I can't even, let me just think instead of reading notes. So radio frequency change on the Earth is going to look like, flight radar going down again, okay? Internet going down, radio blackouts, anything that you can think of that's radio. Your remote controls acting up, your cell phone service acting up, your internet acting up, all of that, okay? So don't be surprised when this hits. You'll see internet outages. You know, what's the graph that shows all the sites that are down? Go check that. Mark my words. Okay? I'm not predicting anything. I am just showing you what's going to happen. Okay? Now, as radio frequencies change, I want you guys to watch out for these superstorms or clouds disappearing and reappearing. Okay? I showed you how we have the jet reversing, and it's causing storms, snow down in Southern California and in Mexico, right? Okay. Um so watch out for storms just appearing out of nowhere, okay, and disappearing. I showed you that hurricane and how intense it got. That almost, I'm still kind of wondering what that was. That sure looked like signs we would see if we experienced some kind of pole shift. So penetrating radiation. So you guys expect some penetrating radiation. That means sunburns, cancerous rays, UV rays coming in. Wear your sunglasses. Don't go out in the middle of the day when the sun's the highest. Um, Calendared superstorms happening early. So uh, this is going to possibly bring a superstorm, all right? And this is due over, the first pass is going over the northern hemisphere of the planet. So I would expect some kind of strengthening of storms, we'll say, and we are having storms right now hitting the west coast that are coming up through the country. Expect those storms to strengthen. They're not only looking ugly right now, but they could possibly strengthen. Then, as we continue up the list, record storms, superstorms. Oh, storm reversal. I showed you the upper atmosphere going backwards. When this pressure hits that upper atmosphere and pushes it down, in fact, let's just go over to this site now. We've stared at that one thing long enough. All right, let me do this real quick because I got a lot to cover here. Now, what I wanted to do was go to the upper atmosphere, to the air, to here. Okay, we're gonna pull this down, get this out of the way. Oh, look at our polar vortex has turned. Oops, it's not one. It's still two. All right. Ooh, it's doing a big old S. All right. Anyways, what I was telling you is this upper air, when this solar wind or this CME hits, it's going to push this flow down onto the lower jet, which is right here. Okay, these storms that are going this way, that upper is going to push down and slow these storms and possibly cause number two, storm reversal. Okay, or the slowing down of storms and slow lingering storms, dumping more snow or rain than they would if they were just passing through. They're going to slow down and hang out a little longer. Then we will get into atmosphere collapse and how that's going to happen next as we take this site, and let me pull over this. Oh, no, I want to go to the air, and yeah, to the air, and we want to come over here to the chemicals. Oh, no, to the chemicals, sorry. And we have the sulfur dioxide that we've been reporting on in our nation bleeding profusely, and it's picking up. This is spreading across the west. Let me turn off the winds, my bad. Okay, pay attention here real quick. So here we are. It's spreading across the west a little bit more. This is intensifying as this inbound object approaches the northern hemisphere. We are seeing this blossom effect here, and it's getting a little stronger now. It kind of pulled away from the southern hemisphere, but now that I look, I see we're having a strong little resurgence again there. Okay, now this is sulfur. Okay, this is the gas that surrounds all the magma underneath being pushed up because of the core expanding, being pushed up through the crust and leaking out through cracks in the ground, right? This is a sign of the volcanic activity. Now, what we're going to have to do now, and I really wanted to avoid doing this part. Okay, so now we're going to go from one chemical to the other. This is nitrogen dioxide, okay? NO2, not N2O. It's not the nitrous that you breathe. It's not laughing gas. This is nitrogen dioxide, okay? And it's a gas that's in our atmosphere, but in small quantities. We need it to breathe, okay? But not too much, not in too strong of quantities. We're going over to the nitrogen now, okay? Did you see the correlation between the nitrogen and our sulfur, okay? This is just like that other map. It's just a different gas that's leaking from the ground. Now, nitrogen is also man-produced, man-made also, so it could be man-made, but it would be around industrial sites, big cities and stuff. And the pollutants that really hang around big cities are carbon monoxide and carbon dioxide, but mostly carbon monoxide. That's the exhaust of everything, all right? So we're going over to carbon monoxide to give you a comparison. We zoom in on anywhere on the planet. You can tell this is carbon monoxide. This is our pollution, all right? LA, the Bay Area, the Valley, this is all pollution. Let's go over to China and you'll really see how it's pollution, all right? Now, see that little spot? That's carbon monoxide. Here's the sulfur. Here's the nitrogen. Okay? So the nitrogen now is leaking from the ground. Okay? This is very important. Okay? Nitrogen is another poisonous gas when in too dense of a quantity. All right? I don't know what the counts are on these, but let's just say not only do they have sulfur in their air, now they are having nitrogen emissions from the ground as well. And these are not the man-made kind. These are the nature-made kind. So we are going to come over. No. I want to go to Wikipedia real quick while we're at this. Something I want to read real quick to you. Let's go down to hydrogen. We're talking about nitrogen dioxide. Sorry. Our NO2. Where'd it go? Okay. First of all, what was the other thing I wanted to read to you? Oh, okay. Nitrogen dioxide is a chemical compound. We'll zoom in just a tad bit on this. All right. It's just real quick. I know this bores everybody, but nitrogen dioxide is a chemical compound with the formula NO2, okay? It's one of several nitrogen dioxides. It's an intermediate in the industrial synthesis of nitric acid, okay? Nitrogen acid, okay? Millions of tons which are produced, blah, 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 blah. Okay, so it's also a chemical compound that man produces. Nitrogen dioxide is paramagnetic, okay? What is paramagnetic? Let's take a little peek. Paramagnetic is a form of magnetism where some materials are weakly attracted by an external magnetic field and from internal induced magnetic fields in the direction of the applied magnetic field. In contrast with this behavior, diamagnetic materials are repelled by magnetic fields. So, it's repelled by a magnetic field coming from the center of the Earth. It is attracted by the weak field, okay, and it's being pulled up out of the ground. It's being pushed up by the core and pulled up by a weak attraction, okay? So this is natural nitrogen coming out of the ground. It's not man-made. Now, since that's the important part, what we need to go down here to is solubility. Solubility in water, it's hydrolysis. So, hydrolysis. Okay. NO2 reacts with water to give nitric acid and nitrous acid. All right. Where was it? Okay. NO2 is induced into the environment by natural causes, including entry from the stratosphere. Okay, this isn't coming from the stratosphere. It's also from bacterial respiration, which is like stuff decaying, like manure. All right. But it does come from volcanoes and lightning, okay? Well, ours isn't coming from lightning. It's got to be coming from the volcanoes, right? The source of the N2O is a trace gas. It's not really abundant. It's just a trace gas in the Earth's atmosphere where it plays a role absorbing sunlight and regulating the chemistry of the troposphere, especially in determining ozone concentrations. Okay, let's go over this last part real quick. It plays a role in absorbing sunlight. When this gas gets up there, it absorbs sunlight, you guys, so that's going to cut back on our sunlight. It's going to block out the sun. Regulating the chemistry of the troposphere. It's going to change the chemistry of the troposphere. That's the upper one that I showed you, especially in determining the ozone concentrations, the ozone layers, okay? This gas is poisonous. It's going to affect the sunlight. It's going to change the chemistry of the troposphere and cause ozone concentrations and depletions, all right? That is atmosphere collapse on the top of the list, okay? So watch out for all these gases coming out of the ground now. All this is all nitrogen as well as sulfur dioxide, okay? These people are getting poisoned and they don't even know it, okay? Let's go back to this one real quick. Here's our hot spot around China. They're in big trouble. This patch was actually black earlier today. I've never seen black reading on this, so there was a patch here that was black. So there's a lot of pressure underneath them, okay? Pushing out a lot of gas. Not only the sulfur, but also the deadly NO2, okay? Oh, what we need to go back to is the solubility. Dang it, I didn't finish on that. So, solubility, where do we go? Hydrolysis reacts with water to reactions. Where to go? Producing, okay. Down here at the bottom, I believe. Environmental effects. Here we go. So, interaction of NO2 or any other NO compound, it could be NO3, NO4, any nitrogen oxide compound mixed with water, okay? Oxygen and other chemicals in the atmosphere can form acid rain, which harms sensitive ecosystems such as forests, okay? This chemical coming out of the ground is going to combine oxygen in the air, creating acid rain, okay? Now, the sulfur in the air is a particulate that water likes to condensate around. So we have more particulates in the air mixed for acid rain. We're going to see heavier amounts of water now because of the extra nitrogen in our atmosphere mixing with the oxygen, taking the oxygen away, by the way, and turning it into water, or turning it into acid rain. So we're going to have less oxygen to breathe and acid rain as a replacement. Okay? And this is an interaction of the NO2 interacting with the oxygen in our atmosphere. So now let's go back to here. Where do you think they're going to see acid rain? Everywhere where the winds are taking this stuff. So now we need to take the winds back on and start looking where our acid rain's going to start flowing. And it's starting to disperse. These plumes right here are of this gas in a lower concentration, okay? This is higher up. So these winds are going to take all this stuff. It's going to mix with the storms out here in the Pacific, funneling storms from the Pacific over America, giving America what? Acid rain. So prepare everybody for acid rain coming here now too, because these two chemical compounds mixed in our atmosphere, like I said, the nitrogen is volatile when it mixes with the oxygen in our atmosphere. The sulfur acts as a particulate for that stuff to latch onto. There has to be like a little piece of dust in the air to create a raindrop, right? So the more particulates you put up there, sulfur emissions, that's like a volcanic eruption in slow motion, invisible, right? All those emissions are still spewing out there, coating the planet with a bunch of particulates, with adding the poison concentration to it, making it volatile. When it rains, it's going to start changing the acidity of our rain around the world. Not just, see, this stuff is getting caught up in storms. Do you see how it's swirling around, getting caught up in storms? It's going to, when it condenses and falls to the ground, it's going to come down as acid rain. It's also coming out of this area, falling here. It's coming out from all around the planet, falling wherever the wind currents take it, okay? And that's mixed with the particulates to stick to it, okay? Look at how much is coming out of China blowing this way. We're getting a double dose of both gases coming across the Pacific, conducting into the storms, and coming into our region, okay? As this effect happens, we're going to have these slow-moving storms dropping more rain. So we're going to have floods of acidic rain, not going to be burning everybody to death, but it does kill the plants, it does kill the animals, it does just ravage nature, let's just say, okay? And this isn't man-made. This is nature's acid rain that we can do nothing about, okay? We got our hands full right now, okay? And that's why I didn't really want to go into the nitrogen dioxide compound, because when you get into the chemical formulations and what's actually going to happen, it gets really ugly. So, but I got to bring that to you because now it's getting out of control. You guys need to be brought, up to speed on what's going on. So, we did that. We did this. We did all. I had something else from this site to show you. Please hang in there. I think you guys are the most patient group I've ever seen. Everybody else is like, no, I did that one. No, let's go here. This one's coming up. All right, we didn't cover the Schumann now. This is what's important. This is the core grinding in its shell, right? Making this hum. This is our electromagnetic hum generated by the dynamo of the core rotating inside the shell. Okay, produces a magnetic field. Magnetic field creates a hum. That hum emanates from the surface of the planet, goes up, bounces off the atmosphere. The atmosphere catches these echoes, and that's what this is. This is the reading of the echoes coming off the atmosphere, and they indicate the squeals, and I've explained these pops and stuff, but what remain concerned right now is this 7.83 hertz line. We just go to 8 right here. This line right here is the one I'm most concerned about. This shows our core activity, okay? I strongly believe that we did have that reversal. This activity is indicative of the reversal. There was a reversal on several of the planets already, so that means we're due, okay? I believe that's the case, and I believe right now we are going forward in reverse, and we're going along pretty strong. Considering the blasts and the impacts we have taken, we are still squeaking along. The old boy may be barely breathing, but the heart of rock and roll is still beating. All right, so let's just go in. I have to remove the camera. Just patience real quick. We'll make this painless and quick. Our latest little patch where it kind of went weak. All right, we had a little dip. It didn't go down entirely, but it did have a dip right in the second line area right here. A little squeal from that dip, see? Okay, but here's today. This is most of today. We did have this little harmonic vibration at what I believe it might be the crust mantle barrier. Okay, radio waves emanating up. The higher the frequency, the closer they are to the core. The lower the frequency, the further away they are. When they slow even more. Okay, frequency slows too. This screech right here at this level seems to indicate maybe a barrier or some kind of barrier line, dividing line in our crust magma strata. Okay? Okay. Glad you guys are hanging in there with me. You guys are awesome. Okay. So our Schumann pumping right along. We're squeaking right along. That's good. Did something else on this site? Oh, yes. We did not do a full report from this site. So let's pull back a little bit. I want to take P. Please come back to me. Thank you. I want to come back and do a full report on this. Please, Lord. Thank you. I've learned to pray for every little... What the... I did not see this earlier. All right, hang on. Sorry, I'm overreacting. I'm overreacting because I'm seeing what I dreaded the most, and I never expected to see this. Oh, dear. Okay, I was going to report on spikes, and I was watching the descent of this because I'm worried about it dropping below the seafloor, right? Remember how I was telling you earlier, if we get below the seafloor into this B range, that's like a yellow. All right, down here should be yellow, and this should be black for death or whatever. I don't know what to call it. Purple. Yeah, you see this color right up here? That's the color this A box should be, all right? I never expected it to even come close to the B floor. I was expecting it to drop from the C to mid B, and we would be in trouble. I don't know what to say. That's the instrument. I was not expecting this. I had the other report pulled up for this, and I am so glad the Lord reminded me to come back and check this instrument. No way. Um, Dang, dude, I'm gonna have to go over to some deeper instruments of the X-ray flux and look at all the different bands and see what happened here. What does that mean? That is not good. I don't know what it means, but let's just say I did not want to see it drop below this level. I thought this would be the danger zone. This would be no man's land. And it did a pretty good deep strike. I've never seen any dip like this ever before. What's this on the list? This is unprecedented uh, unprecedented storms or calendared record superstorm. It would go under records, new record stuff, okay? Because this is a new record. I'm sorry, I don't know how to report thoroughly on this because I was not expecting this. You guys are catching this stuff live with me. You're the lucky audience. I am truly blessed to be able to have this and bring this to you. I'm just so thankful to God for all He's shown me. Hopefully, you guys are understanding what He's shown me. All right, this almost seems like a spiritual event or something. I don't dare say that anymore because some of you have figured it out, some of you never will. Anyway, I can still do my reports. Now, we need to get back to this. This is, I think if we click on it, we can get to the other graph. What? The okay, now this is just sorry. Oh, we went too deep. Come on, back to me. I don't know really exactly what to explain here. This might be some unprecedented activity that is new, like new to science, new to astrophysics. I don't know why there would be such a violent drop in this. See how these react in tandem, okay? They're the same heartbeat kinda, just at lower frequencies, right? I don't know why there would be a bam downward spike like that in one frequency while the other ones are creeping up. Can I get a zoom in on this just a tad bit more from my audience, Lord? Why does it do that? Let's try pulling over. No. All right, well, we're stuck with what we got, but we do need this. Wow. Oh boy, I bet you, I bet you Ben over at Suspicious Observer is going to be scratching his head. I can't wait to hear his explanation for this one. That is the oddest reading, and it's not wrong. This is the GOES X-ray flux. This is the heartbeat of the sun. The sun, dare I say, had a heart attack or something. This is when that was this today? This is the 27th. So this is brand new because I'm looking at impacts. This is brand new. Something just happened that we're not seeing yet. Let's go back over to this. Oh, this one won't have it. You know what? I'm gonna have to come back later. I think you guys with an update because we We just had something happen. Okay, this is disturbing me because I'm talking about earthquakes and all this radioactive activity. And if the sun's doing a weird chemistry change, that's a chemistry change on the sun, I think, you guys. A little bit. This is a result of some kind of disruption. Hitting the flare. That could be. That could be something hitting the sun absorbing some kind of impact, exciting other frequencies while damaging the higher. It looks like maybe it took an impact of some kind, the sun may have. I don't know. I don't know. I've got to think about this one. What would cause such a violent frequency drop? We all know what would cause it to go up. Maybe the core just did something. Now the core of the sun did something. Huh. All right. I'm going to look deeper into it, you guys. Anyways, our Schumann goes X-ray looking crazy. I showed you we have this coming in between us. So we're seeing side effects of this inbound system right now. That's what that is. That is clearly a side effect of our inbound wave. This is X-rays. This is the X-ray flux. This, I wonder if it's going into gamma. If first, this is like the sun like hiccuped or had a slight little heart attack or something. That looks like a little heart attack to me. I mean, I would expect to see a flat line, but down here at B class, that's where I would say the heart attack would be at the B floor. This drops through the C floor, through the B floor, and half into A. I mean, I need a better instrument that tells me exactly what deep it goes. But this is the odd, and we'll back out of it because it's not just that graph, it's that one. I mean, go back through all my data or all my videos. You will never see anything drop below the sea floor, let alone a dramatic spike penetrating the sea floor, B floor, and dropping almost into the bottom of the A floor. All right, there are some other wavelengths and other activity that shows down beneath that I gotta go access. Oh boy. While we're here too, is Jen Miller in the chat? Is Miss Miller here? If you are, speak up and pop yourself into the chat so I know you're here. I got a little bit of part of your stuff that I want to show people, and it doesn't appear she's here. Maybe I'll save it for tonight's later on report or something. But hey, you guys. All right. I was just making a thing saying brace for impact, and you see that we're there's a reason why. Okay, lots of reasons why. There's that, which I was way out of left field. I did not see that one coming. The most important part we will get back to here because I still got a little bit of time left. And this is just utmost important. Oh, auroras. You see how it's getting red here? Expect when this wave hits, you're going to see auroras maybe across the country. They're going to dip lower. And look where they're hitting at right now as opposed to the United States. Let's pull this up. Sorry. Okay. You see how this band is dropping down? When these impacts hit, this is going to flare up really big. I bet you this whole thing might turn red or something, okay? So watch for record auroras out of this, okay? Let me back out of that. I'll probably be doing a report tomorrow night of tomorrow's aurora impact. Kind of forecasting like I had to do when I was a manager. This is also an important image. I don't know if this instrument's going to run, going to play, what's going to do. Oh, there we go. This is NOAA. This is the other site that does the spiral. It's not in motion. They showed this weak little side swipe right here, but this red intensity, and we know this object's coming more this way between the planet and, or up here between the planet and stereo A. So this, I'm not really trusting this reading as much, but it's there to look at. I don't. It does if that's both waves combining and striking at the same time, because this is what we had earlier. Okay, do you see how this impact is more direct right on Earth? Okay, this is more what our impact's really going to look like, I believe, because our object is traveling through here. Do you see it hitting right here, white with the Earth? Okay, this is tomorrow. This is tomorrow's wave hitting. Then here's tomorrow's wave with today or yesterday's. This is the wave that's supposed to hit tomorrow, combining with the one that's supposed to hit yesterday or the day after it for a 1-2 punch. And when you look over here, you'll see it boom, boom. So it's not going to combine together. It's going to be more of a 1-2 punch. But as we kind of need to scoot back over here. Sorry. Okay, they're going to combine. It's going to be a 1-2 magnetic punch. Okay, so that's why I'm saying brace for impact. I would scream red alert, and put exclamation points all over the place and whatever. It is what it is. You guys know what it is. It's a purple alert. It's that dark burgundy color, and you saw what it just did to the GOES X-ray flux. Something's going on with the sun. All right, and now these are objects that cause these ones induced by the passing of those objects. Expect those objects to pass by tomorrow. Hey, you guys, here's a good opportunity to go look up in the sky tomorrow. Most of these objects are dark and you won't see them, but what did I teach you guys? When they're dark, they absorb light. So you're going to be looking for missing light. So look for dark patches in the sky to locate a possible passing object if you're going to videotape something. It will appear as a fuzzy dark patch. It won't look perfectly circular, but the best way to do it is put on some polarized sunglasses, look up at the sky and shift your head around, up and down, left and right, and look around for the dark patch in the sky, the missing light. And that's where your object will be absorbing light in the atmosphere, leaving a dark patch in the sky. Okay? So if you want to see these things, they're hard to videotape. It's hard to get video of them unless you can get a polarized lens on a good camera lens. And if any of you guys got good cameras or polarized lens, this is what you do. You go out and you take that camera, pan around, look for your dark patch, take a little video, rotate it around that dark patch so you can see its central location. Okay, and there might be multiple ones because it appeared that there were multiple objects, and we have that the proton storm that coming with it, the ionized particles, we'll say, that is coming with the second impact, okay? So we might see a little bit of some other, like meteor activity, some shooting stars. We might see a little display, okay? I'm just trying to throw stuff out there as side effects, actual physical side effects to look for, okay? This is very important. I would say this is extremely important. We're going to be experiencing earthquakes from this impact. It could set off volcanoes. Of course, we're going to have weird weather. It's gonna do a doozy on the planet, and it's coming this way. All right, it's not going off the backside. It's not cutting left, cutting right. It's a double impact. Okay. Share this with your friends and your family. Warn them of what's coming. I'll be back a little later with another video. I think maybe in an hour or two. Apparently, I got another appointment I got to go to, so I got to go. I love you all. I'll be back later. Bye.